This is podcast 1.9, and we're going to continue with dimensional analysis, except we're going to make it a little more complicated. We're going to use more than one unit. We're going to have units on the top and the bottom. All right, we're going to do 4 example problems together. Here's our first one. How fast are you going in miles per hour if you are going 15 meters per second? This is different than the problems we have done before because there is this per second. There's divided by some other unit. When you set these up, you're still going to start with what was given in the problem, but it's going to look a little different now because this per second means that that second goes on the bottom. It's like 1 second, but I'm not going to put the 1. So 15 meters per second. And they're asking me to go to miles per hour. So miles and hours. You're going to focus on just one unit at a time. So right now, I'm going to ignore the seconds on the bottom and I'm going to focus only on the meters. I need to get meters to miles. The only conversion factor they gave me has kilometers. So again, you're going to have to do this to figure out how many meters are in a kilometer. Here's the kilometer, here are the meters. Kilometer is bigger, so it gets a 1. And there are 1, 2, 3, so there's 1,000 meters in 1 kilometer. I need to put the 1,000 meters on the bottom and the 1 kilometer on top. I do that so that my meters will cancel. And then I can use the conversion factor they gave me. I can take the 1.6 kilometers, put that on the bottom, and the 1 mile on top. So my kilometers will go away. I'm left with miles, which is what they said I needed. I need miles per hour. So I'm going to stop there. Then I have to go back to the beginning, and now I look at the seconds. I need to get from seconds to hours. I know that there are 60 seconds in 1 minute, and there are 60 minutes in 1 hour. Those are the 2 I'm going to use to go from seconds to hours. So my 60 seconds in 1 minute will get set up like this. That way my second and my second go away. Now I'm in minutes, and then I know that there are 60 minutes in an hour. So minutes on bottom, I'm going to put the 60 minutes on top. And the 1 hour will go down here. Minutes and minutes will cancel, leaving me hours, miles per hour, miles, hours. This is what I need. I'm going to take all this and punch it into the calculator, and the answer you should come up with is 33.75 hours, miles per hour. Okay, and then for significant figures, this number has 2. I'll round my answer to 2. So your final answer will be 34 miles per hour. Next question. A jogger runs a kilometer in 6 minutes. Calculate her speed in meters per second. So this can be a little bit confusing because all I'm seeing is 6 minutes, but they need me to go to meters per second. What I'm going to do is I'm going to use this information to set up my original or my beginning value here. I know that the jogger runs a kilometer. A kilometer is 1 kilometer. And she runs that kilometer in 6 minutes. I set it up with kilometers on top and minutes on the bottom because I need meters on top and seconds on the bottom when I'm finished. So distance over time, distance over time. And just like we did in the problem before this, I'm going to focus on only one part of this at a time. And let's do the time portion of it. Let's do 6 minutes. Minutes needs to go to seconds. So we know that there is, in 1 minute, 60 seconds. So a minute is on bottom. My 1 minute is going to go on top. And I'm going to put the 60 seconds on the bottom. That way my minutes cancel, leaving me seconds, which is good because that's what I need. So that's taken care of. Now I need to go kilometers to meters. And again, we're using this. It's going to be the exact same conversion factor that we used before. Kilometers, meters. Kilometer is the biggest. It gets the 1. There are 3 jumps between a kilometer and a meter. So there's 1,000 meters in a kilometer. And then I'll put the 1 kilometer on the bottom because I need the kilometers and the kilometers to cancel. And I'll put the 1,000 meters on top. I'm finished with the problem because I have meters on top, seconds on the bottom. I'm going to take all of this, I plug it into the calculator, and I get 2.78 meters per second. Looking back at the original problem, 2 significant figures. So my answer needs to have 2, and that would be 2.8 meters per second. Next question. The speed of light is 3.0 times 10 to the 10th centimeters per second. How fast is this in miles per hour? And then they give me a bunch of conversion factors here. I think we're actually missing one, but I can give it to you as we go. So I'm going to start with what we have. 3.0 times 10 to the 10th. Again, centimeters per second means centimeters over, we're going to make this really long, seconds, and that's just 1 second. If we focus on only one part of this, let's do time because it's the easiest. We need to go from seconds to hours. So there are 60 seconds in 1 minute, and that gets my seconds to go away. And there are 60 minutes in 1 hour, and that gets my minutes to cancel. I'm left with hours on the bottom, so my time unit is good. Now I need to worry about my distance. I have centimeters to miles. From what they've given me, I can use this conversion factor first. There is 2.54 centimeters in 1 inch. My centimeter and my centimeter will go away. Okay, now I'm in inches. Inches to feet would be good because then I can go feet to miles. So 12 inches in 1 foot. And they gave me a conversion factor from feet to miles. 5,280 feet on the bottom, that way these cancel. My 1 mile is on top. And I am finished with my calculation because now all I have left is miles on top, hours on the bottom. That's what they asked. So I take all of that, I plug it into the calculator, and I'm going to end up with 6.7 times 10 to the 8th miles per hour. Now if you punch that into your calculator, you came out with a huge number. That has already been converted into scientific notation and rounded to only 2 significant figures to match this one. So the answer in your calculator looks different than this. I have just already converted it into the scientific notation answer. All right, this is the last one. If the density of an object is 2.9 times 10 to the negative 4th pounds, 2.9 times 10 to the negative 4th pounds per cubic inch, what is the density in grams per milliliter? All right, this one is tricky because we're dealing in cubics. So remember, if I see the inches cubed, that really means an inch times an inch times an inch. So we need to think of it when we're doing the problems like this. I'm going to do pounds to grams first because I have a really simple conversion right here. So 1 pound will go on the bottom to cancel this. The 454 grams will go on top. And just like that, I'm in grams. So I've solved the mass portion of this. Now I've got to switch from cubic inches into milliliters. And I'm in inches cubed. And if I look up here, this conversion factor has inches in it. So I'm going to use this one. But I do need to pay attention that this is regular inches, not cubic inches. So how this works is if I put 1 inch right here and the 2.54 centimeters on the bottom, we aren't quite finished because if we remember what we just said, this is really an inch times an inch times an inch, then what happens is this one thing that I put here only canceled one of those 3 inches. So I've got to do it again. And I put the exact same thing in because I'm still trying to get rid of these inches, and then I have to do it one more time. So because it was cubic inches, I had to use that conversion factor 3 times. So that inch gets rid of that inch. This is good because now I have 1, 2, 3 centimeters all here. And if I multiply those 3 centimeters together, I'm going to end up with cubic centimeters, just like I had cubic inches. So this is really the cubic centimeters, which means I can use this conversion factor, and that will take me from cubic centimeters into milliliters. So my cubic centimeters are on the bottom, which means my 1 centimeter cube should go on the top, and my 1 milliliter needs to go on the bottom. That will cancel all of these, and I am left with milliliters on the bottom, grams on the top, which is what they asked me for. So I take all of these, I take the 2.9 times 10 to the negative 4th times 454 times 1 times 1 times 1 times 1, those don't matter, divide by 2.54, divide by 2.54, divide by 2.54 one more time, and if you do all of that, you're going to end up with a decimal that will be too small for you to leave in regular notation, so you're going to have to convert it into scientific notation. And that's what this answer is right here. So, pay attention to the cubics. They do affect how you work your problem. You have to take care of conversion factors and do them 3 times. If you're dealing with cubics, squareds, you would do them twice. But we're going to do a lot of practice with these in class. Don't you worry. And that's the end of podcast 1.9.